1 month ago, I released an alpha demo for my indie game Omapeli. I have been fixing some issues and adding new features like swimming. But guess what? Despite how simple the game looks visually, it runs quite badly even on my desktop PC. So, before I implement the next big features, I want to optimize the game's performance. Hello and welcome, this is an optimization story. Profiling reveals the few hotspots in your code that are worth optimizing. There, even small improvements can have a huge impact. I use two tools to profile my game. The first one is pstats. It graphically shows how time is being spent in updating the game's logic and drawing the 3D world. The second one is Python's cProfile. I use it to get more granular information about how long each Python function call takes to execute. Now, this is the pstats view for Omapeli. The red and the green graphs show the time that it takes for Panda to render the 3D scene that I have made. The red part especially is just the CPU sending to the GPU what to draw in each frame. It is quite bloated because of how I have structured the game world, but that's not important here. Let's say I know how to fix it. I'm most interested on the blue part actually, that shows the time spent in updating the game's logic. If we dig deeper, we will find out that the collision system is doing fine, but it is the other part here that is taking the time. It is here where we start to see potential candidates for optimization. Don't you agree? A prominent one here is this task named Takkahullu saanut, that mainly just recovers health, stamina and magic for each game world object. This can get quite costly when having many entities in the game. First, I changed it here so that instead of all objects starting at half the HP and other stats, they would start at 100% so that they would not have to be updated at all. Second, I changed it so that the trees and other non-living objects that currently greatly outnumber the living objects won't regenerate, meaning that they now can be looped much more efficiently. After these and other minor changes, the rule system now takes an insignificant time of the whole frame's execution. Nice. Then I went back to the pstats and found out that updating the Panda's 3D audio task was taking quite a long time. It turned out that the sounds I added and preloaded to all the NPC characters had their 3D characteristics updated in each frame by Panda, even if the sounds themselves were not playing. This was easy to fix by making changes to my sound class that encapsulates the Panda sounds. Now it adds and removes sounds from the Panda's spatial sound system, depending whether the sounds are playing or not. I also made it lazy so that it loads sounds only when they are played, trusting the catching of the sounds to Panda. Nice. The final optimization target, I found it when I was crossing the terrain tile borders. The spikes here come from the procedural 3D model generation that takes place during the game's runtime. For example, a character's head is created as a sphere by calculating the XYZ coordinates of each vertex and then finding out which vertices have to be connected to form triangles that make up the surface of the model. Examining this process more closely with cProfile, revealed that even to create this simple shape, you have to take a high number of individual steps, and roughly 15,000 function calls as reported by cProfile for the whole character. These numerous small steps in a short time are something that Python is not very strong of. I thought, could this be a job for a compiled language? I re-implemented the sphere creation algorithm in C++ because the Panda3D's core internals are also implemented in it, so the overhead to interface it natively is minimal. It took 2 days to get this done, as I'm not really a C++ expert, but the performance now is in a completely different level. Everything happens around or under 1 millisecond, and cProfile doesn't even actually have the needed clock resolution to report the results correctly. At the same time, I similarly ported my branch creation algorithm to C++. That now speeds up making the character legs, arms, and tree trunks, and their branches. However, with the branches having green leaves, the textured quad cards are still created in Python, and I think porting this part to C++ would result also in tangible gains. Now, after these optimizations, the game's performance is on a much better level. Of course, there are still a lot to optimize, but I think next I'll again focus on adding new features to the game and on improving the gameplay. Thank you very much for watching and sharing this optimization story with me. Happy New Year and see you soon. Bye.